the garden. You know, like if you want to put it down the side of your home, you might choose, you know, a thinner, wider. But if you're just putting it out in the open, you know, maybe you maximize it.
Yeah.
So kind of give me some feedback here. What are you thinking of putting down for that part of it?
Um, I'm trying to think. Fencing.
Yeah,
I'll think about it.
okay. Yeah. Yeah, you don't have to overthink it. It's really just a sentence or two, just to, but you want to put somewhere at the end, determine the lengths of, you know, or basically the length and width of the garden. That's garden. That's terrible. That maximizes the area. Let me type it here. You want to put something at the end that says determine the side lengths that maximize the area. That should be at the end of this thing there. All right, now you're gonna probably not be real happy, but the equation you wrote down in the equation part, you are supposed to use that equation that's given. You don't want to you don't want to add in the plus 20, unfortunately.
I was arguing with the person who sat next to me, and they insisted that the 20 had to go into the equation somehow.
Okay. Well, they could, but I mean, the way I'm sort of thinking through this is it would not. What this is right here is well, how do I want to say this? The domain of your function, which you don't really want to get into, but if you were to graph this, it goes from 0 to 10. And so try to think about if you had a side length that was exactly 10 and another side that was exactly 10, do you have any fencing left over for the other ones?
No.
No, because you've used them all up. So that would be sort of your rebuttal here. If you have class tomorrow, you know, you could say, well, hey, look, if we only have 20, if we only have 20 feet, the most any side could be, the two sides could be is 10 and 10, because then we don't have anything left over. So that's maybe something you could throw in there.
Yeah.
Now the show the work here, you could do a couple of things here, which I think would be good, especially if you were to have to present this to the class, is to label some possible values of like X and Y for your and then you could put something in here like perimeter and then area. So let me show you what I mean by that. And keep in mind here that the X plus Y have to equal 10. Okay. The reason is 2X plus 2Y equals the full fencing. So if you cut that in half, you get this X plus Y equals 10. That's not super important, but what is important is, like, let's say you wanted X to be 1 and Y to be 9. Your perimeter is 20 because your perimeter is 2X plus 2Y. You assume that you're going to use up all of the fencing. Like, you wouldn't just leave some off to the side.
Yeah.
Now, have you ever done any home projects with, you know, mom and dad, or you ever seen them like do tile, or they buy some wood from the store or some PVC or something? Any of that ever happen for you guys?
Yeah.
You always get extra in real life. That's where these problems fall a little bit short, because if you run out or you crack something or breaks and you got to go back to the store, you're just really frustrated. But for the purposes of this problem, assume you use everything. Okay. Your area is X times Y. 1 times 9 is 9. Okay. So now let's say we make x a little bit bigger, 2, 2, and 8. The perimeter is 2 times x plus 2 times y. 2 times 2 is 4. 2 times 8 is 16. That's 20. Your perimeter is always 20. But what's your new area?
8.
X times y.
Oh yeah. So that'd be 16.
16. Okay. So if you wanted to get the smallest garden possible, you would use 9. There might be a reason for that. I don't know, but let's keep going here. Y is 7. Perimeter is 2 times x plus 2 times y. Could you calculate that for us, please?
Uh, 20.
20. But your area is now x times y. 3 times 7 or 20, 21 here. So let's keep going here. Go ahead and fill in the next 2 rows of this table for me, please. How are you doing on this?
Pretty good. Um, for the perimeter, I got 20, and the area got 16.
You're multiplying 4 times 6.
Oh, 24.
24. Good. How about for the next one?
20 and 25.
Yes. Now watch this. When we go the other direction, like let's say we make x 6 and y 4, we actually already have that. And you'll see the numbers start to go down this time. Okay.
Yeah.
All right. So is that kind of okay? What we did there, clear, sort of?
Yeah, makes sense.
Okay. Now we want to determine the side length that maximizes the area. What's the name given to the min or max of a quadratic?
The vertex.
Vertex, yeah. Okay. So notice that when it's in this form, minus x squared plus 10x, we can find the vertex. Okay, so that's a formula. If you recall from the other day, it's x equals minus b over 2a. What is a and what is b in this equation?
A is -1 and B is 10.
Good. Okay, so minus b, or minus b is minus 10 over 2 times -1. What does that reduce to?
5.
5. Now that represents the side of the garden. And so to find the other side, you have to know that the two sides have to add up to 10 up here. Okay, so it shouldn't surprise you because we saw this in the table, but this is what maximizes the formula there. So in terms of like what the teacher is looking for in the show the work, I think I would show a table, and then this right here.
All right.
Let me know when I can move on to the graph here.
You can.
Okay. So there's some question about like, well, what should you even graph? Okay. And there's many answers. Like one thing you might want to graph is the relationship between like x and y, like your side lengths. Okay. Like we found that as one got, let's go back to tables, one got larger, the other got smaller.
Smaller.
Okay. So you might be interested in graphing that. You know, we had 1, 9. This is not to scale, you know, 2, 8, something like that there. Okay. That's one thing you could graph. But I think what you really want is the function itself graphed. I mean, that's why you found the maximum. So your graph, which looks something like this, is a graph of x and then the area of x. The area of x is really though your f of x function. It's the minus x squared plus 10x, and x represents the side length. Okay, so you kind of already have it here. You've got x and then your area function right here.
Yeah.
So you want to just keep going in this table or use the symmetry, the fact that like 7 and 3 is 21,
Yeah.
and then 8 and 2 is 16. So you want to graph the first column with the last column there. All right. So like you've got a ton of grid space there. I think you can go out by, you could probably go out by 2 if you wanted on the X. Like you never want to have a graph that's kind of like all scrunched up over here. Let me see, let me count here. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, so I would probably, I know it's more, I guess I would make this 1, 2, 3, you know, all the way to 10 there.
All right.
And then the other one goes up to 25. The biggest area is 25. So you have some choices here. You could sort of, you know, estimate where it is up here, or um, or you can just go up by twos. You know, you can make this 2, this 4, 6, 8, and so on.
Yeah.
If you have time now, if you're okay to do it now, I would recommend doing that because then it's done. You don't have to.
All right, I got that.
Okay. So hopefully your graph looks something like, you know, wherever 5 is. Oh, have you graphed it? I'm sorry, I didn't know if you did that or not.
Not yet.
Okay, yeah. I mean, if you have, I would recommend plotting, you know, these points, the x values, and then the area values here.
Yeah. Sorry. I got it.
Okay, so you should have something that looks, you know, depending on where your 24 is, but you know, you should have something that looks, you know, roughly like this. You want to connect those there at the end if you can. Does that look similar to what you've got?
Yeah.
Okay. I feel like that's everything for that one. We can go back to the lesson 8.4 notes or something else. You tell me where you would like us to go.
Let's go to 8.4.
All right. Your calculator will be in value before this, and that's good. If you don't have a calculator, and use the formula to find the line of symmetry, find the zeros. Okay. All right. All right, let me snip this in. All right, so we were looking at this last time, this minus gt squared plus vt plus h. G is 16 feet per second, v is the initial velocity, and h is the height at the start. Okay, John hits a baseball 2 feet above the ground with an initial velocity of 42 feet per second. So the G is always 16, v is given, and h is given. Can you give me the equation here? based on those values?
Yeah. Got minus 16x plus, or minus 16x squared plus 42x plus 2.
Good. Now I used t this time. I know we used x last time. Probably was confusing because it should have been t, but the equation you got is good. Okay, so the next part here is to determine the vertex. Okay, it says to determine the maximum height by finding the vertex. So your teacher though is implying that you could graph this, or we can use formulas like we've been doing. What would you like to do for this problem?
Do formulas.
Okay, so the formula here, instead of x, it's t, but t is minus b over 2a. What's your a, b, and c in this problem?
A is negative 16, B is 42, and C is 2.
Good. All right, so you got the minus 42 over 2 times minus 16. Go ahead and calculate that for us, please.
Sure. Negative 1/3.
Negative 42 over negative 32. You can go right to the calculator here. You don't have to even simplify this the way I've done. You can just go right to a calculator. This, if you're using a TI 8384, but you mentioned you're using Desmos, I mean, you can just type it in just like this.
Okay.
You have this value for us?
Yes. It's like 21 over 16.
Yes, but do you need the link to that Desmos? We need the rounded decimal answer.
Okay.
We're going to be using that.
1.3125.
Good. So that's just where the vertex is. Like in terms of the equation here, like that's just the t value. Okay, we want the y value here for the s. So you have to put that value back into the original equation here. So to find the vertex, you're finding the output of 1.3125 minus 16 times 1.3125 squared plus 42 times 1.3125 plus 2. So you get the x, you got to find the y basically.
Got 85.74.
Okay, and that's your answer. With some units here, 85.74. And what do we got here? Feet. Yeah, feet. We got to give some units here.
Perfect.
All right, next thing it's asking for is the time it takes for the ball to hit the ground. So this is the x-intercept. They're just adding some extra information. So we know that it goes up and it comes down, boom, it's there. So you're setting your equation, this original equation here. Let me grab it. You're setting this equation equal to 0. So when you set an equation equal to 0, your options for solving it are factoring, completing a square, or like your instructor said in the other one, quadratic formula. Quadratic formula always works here for this. So A is minus 16, B is 42, and C is 2. Did we talk the other day about how to do this a little more programmatically in the Desmos Scientific?
Yeah.
Like you can enter A equals minus 16, B equals 42, C equals 2, and hit enter each time. And then you can just type in the quadratic formula.
Yeah.
You can't do the plus or minus, but you can do everything else. Would you like to try that again today to see if that makes sense?
Yep. I got negative 0.05 and 2.67.
Okay, so which one is it? Is it the positive one or the negative one?
The positive one.
Yeah, that's it right there. Any questions on that or thoughts?
No.
All right. The profit margins of a company that makes coffee mugs can be modeled by the equation here, in which M is the number of mugs manufactured in thousands. That's important. In thousands is important there. And F of M is the profit in thousands of dollars. Okay, well, they're both in thousands. That's good. Are you a coffee drinker, tea drinker, none of the above?
I think tea is better than coffee.
Tea is better than coffee. And do you like using the mug? Or are you more of a travel mug, or
Mugs are nice.
mugs are nice? Yeah. All right. don't know if this is true or not. It really doesn't matter. See how this, like, this is the story they're providing. That's what your teacher is looking for in that project. Like you to like make something up. I mean, this is, I don't believe this, but for a textbook problem, it is believable. Do you know what I mean by that? Or is that
Yeah.
okay? Okay. Because if you and I were going to make a coffee mug company, I would sure hope we could make more than this. 'Cause, we're going to see here. I mean, this isn't like a ton of money. It's like it's good money, but probably not great money. Like Starbucks isn't using this for their, been there series. If you've seen those coffee mugs when you go in there,
Yeah.
but that's I guess side point is just know that that's what your teacher's looking for, something like that. Um, all right. So how many mugs should be sold to maximize profit? Okay. The profit here function is a quadratic. So again, it's like something like that. So are we looking for something at 1 or at 2 in this problem?
Um, at 1.
Yeah. In fact, we're looking for the y value again. I'm sorry, no. We're looking for just the x value of this. Okay. So it's a lot like the last problem here. A equals whatever, B equals whatever, C equals whatever it is. And then the x value is minus B over 2A.
So A is -3, B is 12, and C is 25.
Good.
But, so X is 2.
Yes, that's correct. Now we got to be careful here. It's 2. What are the units of x or m in this case?
2000.
Yeah, so it's you'd want to have a sentence that says 2,000 mugs. Okay.
Okay.
Now, since we've got the time, I'd like you to put 2 back in the original function here, and let's figure out what what the profit would be.
All right. Uh, 85.
I got a different number. Let me make sure I did this correctly. You put 2 in for this year.
Yeah.
Okay, so so let me just, yeah, because I got a different number here. I got -3 times 2 squared plus 12 times 2 plus 25. So you square first. Maybe that was the error. That's
Yeah. I
4.
think that was. Yeah. So -12.
Plus the 24 plus the 25. Okay.
So 37.
Yes. So that's in thousands. So that translates to $37,000 in profit. Okay. Any questions on that?
No.
Okay. So in business, we'll just talk about like what this actually means in business. So in business, there is what's called revenue. Revenue is you can think of revenue as your cash register. Like let's say you wanted to start selling your I'm gonna use the wrong word here. They're I don't want to call them animations, but is that what it's called?
Yeah.
Is that the right word though? I'm not having a brain.
I mean, like you can sell drawings, I guess.
But they're animations, right? There's not another word for that.
Yeah. It's,
Okay.
I think that's what they are.
Okay. Now let's say someone wanted to pay you for some of your work. Do you have any idea what something you've done might sell for, what a animation might sell for similar to what you've done?
Uh,
Just guessing.
they're like $20, $30.
Okay. So let's pick a nice one. Let's say it's your price is $25, and how many can you make in a week?
Uh, 175.
You can make 175 in a week. That's amazing. That's awesome.
Yeah.
Okay. Well, let's just use 200 because it's an easier number to multiply by. We'll just, you got an extra thing there.
Or wait, do you mean like money or like amount of animation?
So quantity. Yeah. So you said 7, maybe like 1 a day.
Yeah, one a day.
Okay. So let's make 10, just nice round numbers. Okay. So your revenue is 25 times 10 or 250. Okay. Think of like, again, cash registers, like, all right, money's coming in. Great. We're really happy. It's hitting your, PayPal account or whatever you're doing. Do you have any costs associated with your business? Does it cost you anything besides your time to do it?
Uh,
I'm just asking generally. You can just say no or yes or whatever.
no.
Okay. Let's just for simplicity, let's just say that it did cost you like $5 because you had like a licensing thing that you had to use. Okay. And you had to use it for everyone. Okay. So your cost is your license for every one that you made is $50. Your profit, maybe you already know this, but I just thought of maybe an example here would help. Your profit is $200. You take your revenue and subtract your cost. Now, let's just say your competitor over here, they sell theirs for 50, okay? But they can only do 6 a week. Okay, that's 300. But their cost is $25. Like they have a more expensive licensing deal than you do. Okay. 25 times 6 is 150. What's their profit?
150.
150. Who's got the better business right now? Whose is
I
more
do.
profitable? You do. But notice it's not necessarily because your revenue is higher. Their revenue is higher, but your cost is lower. So in business, there's 2 ways to make a profit. You increase revenues or you reduce costs. And both are important.
Yeah.
All right. Well, thank you for letting me spend a few minutes there kind of going through some meaningful situations on